Hello everyone, heartiest welcome on my channel VASISTHA मैथमेटिक्स। और सॉरी पिछले 2-3 दिनों से मैं लाइव नहीं आ पाया, कुछ परेशानियों की वजह से। आज अपने सेशन को आगे बढ़ाते हुए 4th लेक्चर में हम लोग हैं, जिसमें हम लोग बीपीएससी के मेंस ऑप्शनल मैथ्स के डिफरेंशियल इक्वेशन ऑफ हायर ऑर्डर को सॉल्व कर रहे थे। डिटेल सॉल्यूशन हम लोग देख रहे थे। आज के इस सेशन में अपने चैनल पे हम लोग डिस्कस करने वाले हैं। हम लोगों ने 48 तक सारे सॉल्यूशन देख चुके हैं। आज 44, 45, 46 और 47 मेंस के सारे क्वेश्चंस के जो डिफरेंशियल इक्वेशन ऑफ हायर ऑर्डर के हैं उसके डिटेल्ड सॉल्यूशन देखेंगे। और कल हम लोग अपने इस सेशन को फिनिश करेंगे, यानी 40 से लेकर के 43, 40, 41, 42 और 43 के सारे क्वेश्चंस को देख लेंगे कल हम लोग, जो भी टाइम लगे। और तब हम लोग उसके बाद पार्शियल डिफरेंशियल इक्वेशन स्टार्ट करेंगे, जो कि सेक्शन 2 का पार्ट था हमारा। तो देर नहीं करते हुए हम लोग, चूंकि आज बहुत सारे क्वेश्चंस हैं, उन सारे क्वेश्चंस के सॉल्यूशन को स्टेप वाइज हम लोग देखते चल रहे हैं। आज का जो पहला क्वेश्चन है हमारा, वो है बीपीएससी में 44th का। इक्वेशन है x y स्क्वायर माइनस 1 इंटू डी एक्स प्लस वाई इंटू एक्स स्क्वायर माइनस 1, सॉरी यहाँ डी वाई होगा, डी वाई इक्वल टू 0। तो बहुत ही आसान सा क्वेश्चन है ये। क्या करें, सबसे पहले वेरिएबल सेपरेबल के फॉर्म में इसको लिख देते हैं, यानी x इंटू वाई स्क्वायर माइनस 1 इंटू डी एक्स इज इक्वल टू माइनस वाई इंटू एक्स स्क्वायर माइनस 1 इंटू डी वाई। एक्स वाले को एक तरफ, वाई वाले को एक तरफ, एक्स अपॉन एक्स स्क्वायर माइनस 1 डी एक्स इक्वल माइनस वाई डी वाई अपॉन वाई स्क्वायर माइनस 1। प्योर वेरिएबल सेपरेबल पे आ गया हमारे। अब हम लोग इसको इंटीग्रेट कर दें। इंटीग्रेट करने के पहले अगर नीचे के टर्म को देखें तो इसका डिफ्रेंसिएशन ऊपर है। अगर यहाँ 2 हो जाए तो इधर भी 2 से मल्टीप्लाई कर दे रहा हूँ और इधर भी 2 से मल्टीप्लाई कर दे रहे हैं, तो नीचे का डेरिवेटिव ऊपर आ रहा है। एक्स स्क्वायर माइनस 1 अगर u है तो 2x dx du है, दैट इज du अपॉन u। इफ दिस इज योर z, then this is your 2y dy is your dz, that is du upon u. This will give log of x square minus 1. This will becomes minus log of, and adding a arbitrary constant as log c, integral constant। और यहां से हमारा log of x square minus 1 plus log of y square minus 1 is equal to log of c, and using the properties of log, this is log m plus log n. This will become log of m into n equal log of c, that is x square minus 1 into y square minus 1 will be c. This is the required solution of the given differential equation. This is the required answer. Okay, this is our first question. Come for the next question. This is also BPSC main 44th and linear differential equation of higher order. साथ ही साथ अगर ध्यान दीजिए तो आपको ये दिखाई देगा लीनियर डिफरेंशियल इक्वेशन होमोजीनियस के टर्म में। होमोजीनियस की क्या पहचान है? एक्स का जो डिग्री है वो हमारे डिफरेंशियल कोफिशिएंट के ऑर्डर के बराबर होना चाहिए। ये 4 ये भी 4 3 3 2 2 एक्स का डिग्री 1 ऑर्डर 1, यानी कि ये डिफरेंशियल इक्वेशन हमारा होमोजीनियस डिफरेंशियल इक्वेशन है। यानी कहने का मतलब थोड़ा सा अगर इसके कॉन्सेप्ट के बारे में बात करें तो कह सकते हैं कि एक ऐसा लीनियर डिफरेंशियल इक्वेशन जो ए नॉट एक्स टू द पावर एन डी एन वाई बाई डी एक्स टू द पावर एन प्लस ए वन एक्स टू द पावर एन माइनस वन डी एन माइनस वाई अपॉन डी एक्स टू द पावर एन माइनस वन एंड सो ऑन a n minus 1 x into dy upon dx plus a n y equal to x. Then where define कर दे कि a1 a naught a1 dot 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 a n belongs to constant and x also belongs to constant और फंक्शन ऑफ एक्स ओनली, या तो कांस्टेंट हो या फंक्शन ऑफ एक्स ओनली हो। तो इस तरह के इक्वेशन को हम लोग, यानी कि ये जो गिवन इक्वेशन है, दिस इक्वेशन इज नोन एज होमोजेनियस लीनियर डिफरेंशियल इक्वेशन एंड दिस इज आल्सो नोन एज कॉची-यूलर इक्वेशन। Cauchy-Euler differential equation, linear differential equation। और होमोजीनियस लीनियर डिफरेंशियल इक्वेशन को सॉल्व करने के लिए हम लोग क्या करते हैं? सब्स्टिट्यूट करते हैं x इक्वल e टू द पावर t, दैट इज log of x इक्वल t, and from here 1 by x dx is your dt and 1 by x equal dt upon dx। ठीक है, अब अगर dy by dx हमें निकालना हो तो थोड़ा सा देखें, तो dy by dx and dy by dx can be written as dy by dt into dt by dx, and dt by dx is our 1 by x, that is dy by dx 1 by x and dy by dt, that is x dy by dx becomes dy by dt, dy by dt, and say this x dy by dx as d of y, where d is your d by dt. Similarly, x square d2y by dx square will become d into d minus 1 into y. Similarly, x cube, अच्छा यहाँ पे थोड़ा सा गड़बड़ आ जा रहा है क्योंकि यहाँ फोटो आ रहा होगा ना, पिक्चर आ रहा होगा, इसको मैं यहाँ से हटा देता हूँ। यानी x dy by dx का मतलब है d of y। Similarly, x square d2y by dx square can be written as d into d minus 1 into y. यहाँ हम लोगों ने लिखा था x dy by dx equal d of y, where your d is your, जहाँ d का मतलब है d upon dt. Similarly, x cube d3y by dx cube can be written as d minus 1 d minus 2 into y. Likewise, we can write the differential equation as x4 d4y by dx4, that is the equation becomes d4, that is 3 terms, d minus 1 d minus 2 and d minus 3, again plus 2x cube means d minus 1 d minus 2, x square d2y by dx square, that is d minus 1 minus x dy by dx, that is minus d, and here is your y, that is plus 1, as y taken common from all the term. This becomes equal log x, and our log x is your t, because capital D denotes d by dt, therefore this log x should also be converted into t. Now this becomes d. Just solve this and we get d, multiply this, we get d cube minus 32516 d square plus 628311 d minus 6 plus twice d. This becomes d squared 2 plus 1 3d plus 2 plus d square minus d minus 2d plus 1 into y is equal to t, और एक step. So this becomes d4 minus 6d cube plus 11d square minus 6d plus 2d cube minus 6d square plus 4d plus d square minus 2d plus 1 into y equal t. Arranging all the term, we get d4 minus 6 d cube 11 d square 12 d square minus 6 plus this is d cube, sorry, 6 minus 2 4 d cube, this is 4d cube plus 11d square 12d square minus 6 6d square, again 4d 6d 6 to 8 plus 4 minus 4d and plus 1 into y equal t. That is, this whole term becomes d minus 1 to the power 4 into y equal t. Now, for the complete solution, we will have to find the CF as well as PI. Okay. For CF, this is d minus 1 to the power 4. That is m minus 1 to the power 4 equals 0. That is, we have value of m as 1, 1, 1, 1, the root of auxiliary equation. And the CF is C1 plus C2. Equation is in form of dy by dt, that is t plus C3 t square plus C4 t cube e to the power mt. M is your 1 into t. That is, put the value of t. T is your log of x. That is, this becomes C2 log x, C3 log of whole square, C4 log of x to the power 4 into e to the power t, and here e to the power t is your x. This is the complementary function. This is your CF. Now for PI, this will equal 1 by f of d and x, and f of d is our 1 upon d minus 1 to the power 4 and x as t, and this can be written as, because this is even power, this can be also written as 1 minus d to the power minus 4 into 2 into t, expansion of 1 minus d to the power minus 4, 1 plus 4d plus 10 d square plus 20 d cube and so on of t, that is t plus 4 d by dt of t, this will be 1, and in next step all will be 0, and the value of t is your log x, that is 4 plus log of x. Therefore, for complete solution, this will be y equal C1 C2 ln x, C3 ln x whole square, C4 ln x to the power 4 into x, this is your CF, plus PI, that is 4 plus ln x. This is the complete solution of the given differential equation. Okay, come for the next one. Orthogonal trajectory of the cardioid are equal to a into 1 minus cos theta. Also, this question is from BPSC main 44th. This is the polar equation, and for polar equation, just take a log, then differentiate, and for polar, differentiate given equation and eliminate the arbitrary constant. Here a is arbitrary constant, eliminate the arbitrary constant, and then replace dr by d theta by minus r squared d theta by dr. This is our working rule to find the orthogonal trajectory of the polar curve. Okay. Now our equation is r equal a 1 minus cos theta. We have to find orthogonal trajectory, that is all the family of tangent which are perpendicular to each other. For this, taken log, that is log r equal log of a, the log of 1 minus cos theta, differentiating with respect to theta, this becomes 1 by r dr by d theta, this 0, the differentiation of log 1 by x and the cos theta minus sin theta, minus minus plus 1 minus cos theta. Solve this, this becomes twice of sin theta upon 2 cos theta upon 2, 1 minus cos theta 2 sin square theta upon 2, that is cos upon sin gives cot theta by 2. That is we get 1 by r dr by d theta as cot theta by 2. That is r. D theta by dr becomes tan theta by 2. This is our equation. Now replace r d theta by dr. Here we are doing minus r square d theta by dr, that is r d theta by dr can be replaced by minus 1 by r dr by d theta. That is replace, बात एक ही है, हमारे पास है यहाँ r d theta by dr, यहाँ चाहिए माइनस r स्क्वायर, तो रिप्लेस मतलब इसको इससे कीजिए या इसको इससे कीजिए, तो r d theta by dr को रिप्लेस r minus r square, that is here it should be minus 1 by r dr by d theta. तो इक्वेशन 1 क्या हो गया हमारा, r d theta by dr की जगह ये हो गया माइनस 1 by r dr by d theta माइनस 1 by r dr by d theta equal tan theta by 2. Variable separable, that is dr by r equal minus tan theta by 2 d theta. This becomes log of r minus log sec theta by 2 and coefficient of theta is your 1 by 2 plus c. This becomes log cos theta by 2 to power minus 1 or minus log cos theta by 2 minus minus plus. This becomes log r equal twice log cos theta by 2 plus c, that is log r. Just for convenience, put c as log c. Put c as log c, that is log r minus log c log cos square theta by 2, that is r upon c becomes cos square theta by 2, that is r becomes c cos square theta by 2, c cos square theta by 2. Therefore r equals c and cos square theta by 2 can be written as 1 plus cos theta upon 2, that is r becomes c by 2 into 1 plus cos theta and say k as constant, where k equal your c by 2. This is the required orthogonal trajectory for the cardioid, and this is also cardioid. This is the orthogonal trajectory for the given cardioid are equal to a1 minus cos theta. Okay. नेक्स्ट वन प्लस वाई स्क्वायर dx, ये तो आसान क्वेश्चन है, लीनियर डिफरेंशियल इक्वेशन जैसा दिख रहा है, ये 45th का क्वेश्चन। सबसे पहले मैंने छोड़ दिया है यहाँ dy, क्वेश्चन थोड़ी सी गड़बड़ प्रिंट हो गई। द क्वेश्चन इज 1 प्लस वाई स्क्वायर dx इक्वल tan इनवर्स y minus x into dy and dx upon dy becomes tan inverse y minus x upon 1 plus y square. This can be written as separating tan inverse y upon 1 plus y square minus x upon 1 plus y square and dx by dy plus x upon 1 plus y square equal, this is your linear differential equation, plus p into x equal q, where p is the function of y and q is also the function of y. Thus we will find if LDE, linear differential equation, and for linear differential equation we will have to find the value of if, integrating factor. This is your e to the power integration of p dy if the equation is in term of dx upon dy. This becomes e to the power integration p. P is your 1 by 1 plus y square, 1 by 1 plus, that is dy, e to the power tan inverse y. Thus if is e to the power tan inverse y. Now for solution we can write, in general for dy by dx the solution is y into if, but in term of equation dx by dy this can be written as x into if, integration of q if dy plus c. X if is e to the power tan inverse y and q is our tan inverse y upon 1 plus y square. Into if is e to the power let t equal e to the power tan inverse y. Then dt becomes e to the power tan inverse y upon 1 plus y square dy. That is this whole tan inverse y. Say t equal to tan inverse y only. T equal tan inverse y and dt equal 1 upon 1 plus y square dy. Now tan inverse y is your t, the equation is x e to the power t e to the power t and dy upon 1 plus y square becomes your dt. Integration by part, t e to the power t minus d by dt of t1 and e to the power t integration again e to the power t. This becomes e to the power t into t minus 1 plus c, and the solution is x e to the power tan inverse y e to the power tan inverse y dividing by e to the power tan inverse y. This is tan inverse y minus 1 plus c e to the power minus tan inverse y. This is the required answer of the given differential equation. Okay. For next one, we have to find the orthogonal trajectory of the family of the curve x square plus y square plus 2fy plus 1 equal 0 where f is parameter. स्पीड थोड़ा बढ़ाते हैं, क्वेश्चंस बहुत सारे हैं. We have orthogonal trajectory. Just first we will find dy by dx and we will replace dy by dx as minus dx by dy, because for orthogonal trajectory the tangent must be perpendicular. If the value for two perpendicular tangent, if the slope of first is m, the another will be minus 1 by m. This is why we will replace dy by dx by minus dx by dy. Okay, differentiate the given differential equation and find dy by dx. This gives 2x, 2y, dy by dx, 2f, and dy by dx is equal 0. Okay. From the given equation, we can write 2fy equal minus 1 plus x square plus y square. Differentiating this, 2f dy by dx minus 2x 2y by 2 dy by dx. Okay. Dividing this two, we get 2f dy by dx upon 2f of y equal minus 2x 2y dy by dx upon minus 1 plus x square plus y square. This 2f becomes cancel, minus minus cancel, and 1 plus x square plus y square dy by dx equal 2y into 2y into 2 can be 2, taken 2 common, 2y x plus y dy by dx. Okay, now replace dy by dx by minus dx by dy. Now the given equation will become 1 plus x square plus y square minus dx by dy equal 2yx plus y, 2y x plus, in place of y, plus minus dx by dy, minus y, and this is your dx by dy. Okay, 2y square dx by dy, and this is dx by dy. Taken dx by dy as common. This is minus 1 minus x square minus y square plus 2y square, twice of xy, and dx by dy into y square minus x square minus 1 equal twice of xy, and dx, and this becomes 2xy dy by dx, 2xy dy by dx equal y square minus x square minus 1, 2y dividing by x, 2y dy by dx equal y square by x minus 1 by x, 2y dy by dx minus y square by x equal minus x square plus 1 upon x. 2y by dy by dx, put y square as v, put that is 2y dy by dx equal dv, and now the equation will become LDE, linear differential equation. 2y by dy by dx becomes dv by dx, and the equation will become 2y dy by dx is dv upon dx minus 1 by x into v minus x square plus 1 upon x. This is your linear differential equation, and if e to the power minus 1 upon x dx, that is e to the power minus ln x, x to the power minus 1, that is 1 upon x. If is your 1 upon x. And for solution, y, that is in place of y, this is v into if integration q, that is minus x square plus 1 upon x into if 1 by x dx plus c. Put the value of v, that is y square, this is your y square upon x minus x square, this becomes 1 plus 1 upon x square dx plus c, and this is your y square upon x equal minus x minus 1 by x minus minus plus, this is your plus 1 by x plus c, taken LCM x cancel, and y square equal minus x square plus 1 plus cx, that is x square plus y square plus cx plus 1 equal 0. Just put x square plus y square, in place of c just put 2gx plus 1, this is minus 1, minus 1 equal 0. This is a circle whose center is your minus 3 and 0. This is the required answer. This is the orthogonal trajectory of the given circle. This is the required answer of the given question. This is the orthogonal trajectory on the given curve. Okay, of the family of the circle. Okay. Again, LD 445th. d2y by dx square 3dy by dx plus 2y e to the power 2x sin x. बहुत बार ऐसा क्वेश्चन किया हम लोगों ने, फिर से देखते हैं एक बार क्या करें। सबसे पहले इसके लिए ऑक्सिलरी इक्वेशन का फॉर्मेशन करें। इट इज डी स्क्वायर प्लस 3d प्लस 2 into y equal e to the power 2x sin x, and its auxiliary equation is m square 3m plus 2 will be 0, and this is your m plus 2 into m plus 1 equal 0, and m is your minus 2 minus 1, and CF roots are different, e to the power minus x, C2 e to the power minus 2x. This is our CF. For PI, 1 by f of d of x, that is our FD is 1 upon d plus 2 into d plus 1, that is d square plus 3d plus 2, and this is e to the power 2x sin x. E to the power x into any types of function, then we will put the coefficient of x as 2 in place of d plus 2. The equation will become 1 upon e to the power 2x d plus 2 whole square plus thrice d plus 2 plus 2 of sin x. In next step, pi e to the power 2x 1 upon, this becomes d square 4d 3d 7d, d square plus 7d plus 4 2 6 plus 6 12. Sin x, the coefficient of x is 1, और जहां डी स्क्वायर होता है वहां पर हम लोग माइनस 1 का स्क्वायर प्लस 7d प्लस 12 sin x, यानी स्क्वायर की जगह ही केवल प्लेस कर सकते हैं, तो 12 माइनस 1 11, 1 अपॉन 7d प्लस 11 इंटू स्क्वायर के लिए अगेन 7d माइनस 11 से न्यूमरेटर डिनोमिनेटर में गुना किया, ये आ गया sin x, अगेन e का पावर 2x, और ये आ गया 7d माइनस 11 बटा 49 डी स्क्वायर माइनस 121 sin x, फिर डी स्क्वायर दैट इज e टू द पावर 2x इंटू 1 अपॉन 49 माइनस 1 स्क्वायर माइनस 21 7d माइनस 11 sin x, ये माइनस 49 एक 50 20 70, दैट इज माइनस 170 e to the power 2x 7 differentiation of sin x cos x माइनस 11 sin x। ये हमारा पी आई आ गया। यानी फॉर कंप्लीट सॉल्यूशन, फॉर कंप्लीट सॉल्यूशन y इक्वल टू cf प्लस पी आई and our cf is c1 e का पावर माइनस x, c2 e का पावर माइनस 2x, c1 e का पावर माइनस x, c2 e का पावर माइनस 2x प्लस पी आई एस माइनस 1/70 माइनस e टू द पावर 2x by 170 7 cos x minus 11 sin x। Required answer of the given question। आगे बढ़ते हैं। क्वेश्चन है sin y dy by dx इक्वल cos x 2 cos y माइनस sin स्क्वायर x। ये भी 46 sin y dy by dx। Just put t equal to cos x, सॉरी cos y, t equal to cos y, तभी तो मिलेगा हमें dt by dx माइनस cos का डिफरेंस माइनस साइन, तो माइनस इधर कर लिया, एंड sin y dy by dx। यानी इक्वेशन हमारा क्या हो गया अब, sin y dy by dx की जगह माइनस dt अपॉन dx, और ये हो गया cos x 2t माइनस साइन स्क्वायर एक्स, यानी आ गया माइनस dt by dx माइनस 2t cos x इक्वल माइनस साइन स्क्वायर एक्स cos x, माइनस हटा लिया तो dt by dx प्लस 2t cos x इक्वल sin square x cos x। This is our linear differential equation। Again find pi, which will be e to the power integration p, that is the coefficient of t, that is 2 cos x dx, and this will be e to the power twice of sin x। This is our pi। Now for solution, equation in term of dt upon dx, that is t into if, e to the power twice of sin x, integration q into if, that is e to the power twice of sin x, and q is our sin square x into cos x, sin square x into cos x dx। Let z equal sin x, dz equal cos x dx। Now the equation becomes, put the value of t, which is cos of y e to the power twice of sin x, integration e to the power 2z sin x z, this becomes z square, and cos x dx is your dz, integration by part, which can be written as z square e to the power 2z, integration e to the power 2z upon 2 minus integration d by dz of z square, this becomes 2z, integration of e to the power 2z, e to the power 2z upon 2 dz, again integration by part, that is cos y e to the power twice of sin x z square e to the power 2z by 2 minus Again, z e to the power 2z by 2 minus d by dz of 1 e to the power 2z e to the power 2z by 2, again integration of e to the power 2z by 2, 2 to the 4. This is your plus c. This becomes cos y e to the power twice sin x 1 by 2, z is your sin x, sin square x e to the power twice sin x minus z sin x by 2 e to the power twice sin x plus 1 by 4 e to the power 2 sin x plus c. Dividing by e to the power 2 sin x, the equation, the solution will become cos y 1 by 2 sin square x minus 1 by 2 sin x plus 1 by 4 plus c e to the power minus 2 sin x. Desired equation, desired solution of the given equation. For next, dqy by dx cube minus 2 d2y by dx square minus 19 itna equal this. Okay, this is your question related to 46th BPSC. The equation can be written as dq minus twice d square minus 19d plus 20 into y equal x e to the power x plus twice e to the power minus 4x into sin. Auxiliary equation is your m cube minus 2m square 19m plus 20 equal 0. At m equal 1, 20 and 1 21 minus 21 equal to 0. This becomes m square m minus 1 minus m minus 1 minus 20 m minus 1 equal 0. That is m minus 1 m square minus m minus 20 equal 0 and m minus 1 m minus 5 m plus 4 equal 0 and the root is 1 5 minus 4. Distinct root, therefore complementary function CF equal C1 e to the power x, C2 e to the power 5x, C3 e to the power minus 4x. This is your CF. For AI, for PI, 1 by FD, 1 by FD. D is our D minus 1, D minus 5, D plus 4. Into x e to the power x plus 1 upon d minus 1, d minus 5, d plus 4, 2 e to the power minus 4x, 2 e to the power minus 4x into sin x. Okay. The first part, that is x e to the power x. Coefficient of x is 1, that is e to the power x 1 upon d plus 1 minus 1, d plus 1 minus 5, d plus 1 plus 4, x e to the power sorry x. And this becomes e to the power x 1 upon d, and this becomes d minus 4 d minus 4 into d plus 5. This is equal to e to the power x 1 upon d, and this is your d square minus 4d plus 5d plus d minus 20 into x. Okay. In next step, e to the power x 1 upon d, and this can be written as taken minus common. This becomes 20 minus d square minus d, that is 1 by 1 plus 19 minus d square minus d of x, and minus e to the power x 1 by d, and this becomes 1 plus 19 minus d square minus d to the power minus 1 into x, and this becomes minus e to the power x 1 upon d 1 minus 19 1 minus 19 minus d square minus d dot 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 into x, आगे की जरूरत ही नहीं पड़ेगी, that is minus e to the power x 1 by d. This becomes x minus 19x minus d square of x, that is differentiation of x1 0, and this is your plus 1. This becomes minus e to the power x 1 by d of, arranging this, 1 minus 18x 1 minus 18x, and integration, that is 1 by d, integration of 1, this is x minus 18 x square by 2 x minus 1 by d minus minus plus minus 18x minus 1 19 1 minus 19 minus minus plus, okay, 1 minus 18x, that is this will become e to the power x 9x square minus x, और अच्छे से इसको अरेंज करें तो x e to the power x 9x minus 1 19 18 9x, ठीक, x e to the power x 9x, ये एक मिनट थोड़ा साइन देख लें, ये दोनों माइनस होगा, ठीक है, 1 minus 19 minus d square minus 18d plus d square plus d, ठीक, minus 19 1 x माइनस 19 x, 2 बार 0 एक बार 1 डिफ्रेंसिएशन। ठीक है, ये हो गया ये। अब इसका अगर हम लोग निकालें, ये भी थोड़ा बड़ा ही जाएगा। नेक्स्ट पार्ट के लिए पी आई 2 कांस्टेंट बाहर निकल गया, e टू द पावर माइनस 4x, कोफिशिएंट ऑफ e is -4, this becomes d minus 4 minus 1, d minus 5, d minus 4 minus 1 into d minus 4 minus 5, कैलकुलेशन है, d minus 4 plus 4 into sin of x। तो झटझट करें, 2 e to the power minus 4x 1 upon, this becomes d into d minus 5 and d minus 9 sin x, that is 2 e to the power minus 4x 1 upon, this is d into d square, 9 5 14 minus 14 d square, 9 5 45 d 45 d, और d स्क्वायर साइन का टर्म है तो हमें d स्क्वायर का टर्म चाहिए, 45 d sin x, and this becomes twice e to the power minus 4x 1 upon d minus 1 x का कोफिशिएंट minus 14 minus 1 का स्क्वायर प्लस 45d इंटू साइन x, और ये हो गया ट्वाइस e टू द पावर minus 4x 1 अपॉन minus d plus 14, that is 44d minus 14, 44d और minus minus plus 14 into sin x, taken 2 as common, 2 cancel, and this equal e to the power minus 4x 1 by 22d plus 7 into sin x, this gives e to the power minus 4x and 22d minus 7, 484 d square minus 49 into sin x, that is e to the power minus 4x 22d differentiation of sin cos x minus sin 7 sin x, coefficient of x 484 minus 1 square minus 49, यानी कि ये आ गया माइनस 1 अपॉन 4 9 13 8 4 12 1 13 4 1 5 533 e to the power minus 4x and 22 cos x minus sin x, यानी ओवरऑल अगर पीआई पे देखें हम लोग, आंसर अगर इसका, एक मिनट, यानी फाइनली अगर इसका आंसर हम लोग लिखें तो कंप्लीट सॉल्यूशन y equals cf and cf is our c1 e to the power x C1 e to the power x, C2 e to the power 5 minus 4, 5 minus 4, 5x minus 4x plus first part of pi. This is our x e ka power x, 9x minus 1 plus x e ka power x, 9x minus 1 plus minus minus 1 by 53, 533 e to the power minus 2x into minus 4x, sorry, e to the power minus 4x into 22 cos x minus sin x, 22 cos x minus 7 of, this is the required answer. और कितने क्वेश्चंस हैं? 9, 10, 11, 12, ओके 4 क्वेश्चंस और 4 क्वेश्चंस हैं, इजी है सब, देख लेते हैं। और टेंजेंट लाइंस टू द पैराबोला y इक्वल टू एक्स स्क्वायर, ठीक है, टेंजेंट जब भी होगा तो किसी न किसी पॉइंट पे ही होगा। तो लेट पॉइंट इज, if x is your a, then the y will be your a square, and tangent line that is differentiates y with respect to x, and dy by dx becomes 2x, and tangent at any point a square will be your 2a. Equation of tangent. This is your y minus y1 dy by dx at any point into x minus x1. This becomes y minus a square equal 2ax minus 2a square. That is y equal 2ax minus a square. Now differentiate dy by dx equal to 2a, dy by dx equal to 2a, and find the arbitrary constant, that is a equal 1 by 2 into dy by dx. Now the equation of tangent is from this, from 1 y equal to ax, from 1 we have y equal to ax minus a square. Just put the value of a to x, and the a is your 1 by 2 dy by dx. Meaning of a square is 1 by 4, and dy by dx whole square. 2 becomes cancelled, and the y becomes x dy by dx minus 1 by 4 dy by dx whole square. Thus this becomes 4y equal 4x dy by dx minus dy by dx whole square, and the equation is dy by dx whole square minus 4x dy by dx plus 4y equal 3. This is the differential equation of all tangent line to the given parabola y equal to x square. Now the question, xy sin xy plus cos xy y dx plus xy sin xy minus cos xy x dy. Okay, for this question दिस इज द क्वेश्चन ऑफ एग्जैक्ट डिफरेंशियल इक्वेशन। दिस इज एग्जैक्ट डिफरेंशियल। अभी ये एग्जैक्ट नहीं है, एग्जैक्ट बनाना होगा। यानी हमारा ये फॉर्म है एम डी एक्स प्लस एम डी वाई। जहां हमारे पास m है एक्स वाई साइन एक्स वाई cos xy to y, and we have n equal xy sin xy into x. That is, this equation is in the form of the given equation. This one is in the form of f1 xy into y dx plus f2 xy x dy equals 0, and for in this condition the if of equation 1 will be 1 upon mx minus ny, where mx minus ny never equal 0. Just find the value of mx माइनस एन वाई, और तब हम लोग इस आई एफ से मल्टीप्लाई कर देते हैं और तब उसको एग्जैक्ट के फॉर्म में हम लोग लाते हैं। एग्जैक्ट के लिए क्या था, डेल एम बाई डेल वाई इक्वल टू डेल एन बाई डेल एक्स। अगर ये कंडीशन सेटिस्फाई होता था, यानी कि डेल एम अपॉन डेल वाई इक्वल डेल एन बाई डेल एक्स, देन द इक्वेशन विल बी एग्जैक्ट। और तब m को इंटीग्रेट करते थे y को कांस्टेंट ट्रीट करते हुए, और x dx और जो टर्म होता था बाद वाला यानी कि dy वाला, उसमें हम लोग x को एलिमिनेट करके y वाले टर्म को इंटीग्रेट करते थे। तो वही काम करेंगे, mx माइनस एन वाई पहले निकाल लेगा, x से मल्टीप्लाई करें m में तो यहाँ भी एक्स वाई है, इसमें मल्टीप्लाई करें तो इसमें भी एक्स वाई है। एक्स वाई एक साथ अगर कॉमन ले लें हम लोग तो आ गया एक्स वाई साइन एक्स वाई प्लस कॉस ऑफ एक्स वाई माइनस एक्स वाई साइन एक्स वाई एंड माइनस माइनस plus cos of xy. This becomes cancel, and this becomes 2xy cos of xy. That is if आ गया 2xy cos of xy 1y, यानी if 1 upon, that is 1 upon 2xy cos of xy. Now multiply by इक्वेशन 1 को हम लोगों ने मल्टीप्लाई किया हम अपने आई एफ से, तो इक्वेशन क्या हो गया हमारे पास, एक्स वाई साइन एक्स वाई 1 बाई 2 एक्स वाई कॉस वाई। सबसे पहला तो 1 बाई 2 बाहर निकाला, और ये हो गया y एक्स वाई, y बिकम कैंसल, x खत्म तो y tan एक्स वाई, y tan एक्स वाई प्लस cos एक्स वाई कैंसल, y से y कैंसल खत्म हो ही गया तो 1 बाई 2 निकाल लिया, 1 बाई एक्स डी एक्स प्लस अगेन 1 बाई 2 एक्स tan एक्स वाई माइनस cos एक्स वाई खत्म, x खत्म तो बच गया माइनस 1 बाई वाई डी वाई। अब ये हमारा एग्जैक्ट आ गया। आप देख लो m को y के रिस्पेक्ट में डिफ्रेंशिएट करके tan एक्स वाई आ जाएगा, n को यानी 1 बाई 2 खत्म, और ये n हो गया, n को आप y के रिस्पेक्ट में डिफ्रेंशिएट करो, x के रिस्पेक्ट में डिफ्रेंशिएट करो तो tan एक्स वाई यहाँ भी आएगा, यानी कि ये एग्जैक्ट आ गया। एग्जैक्ट आ गया तो हम लोग इसमें y को कांस्टेंट मानते हुए इंटीग्रेट करेंगे, ये 1/2 इंटीग्रेशन y एज कांस्टेंट, तो ये y tan xy प्लस 1/x dx प्लस x के टर्म को हटा दिया, 1/2 इंटीग्रेशन माइनस 1/y dy इक्वल, इधर कुछ कर लेते हैं 1/2 log c, 1/2 खत्म, ये हो गया। y कांस्टेंट, y बाहर निकल गया, log sec xy, x का कोफिशिएंट y से डिवाइड प्लस 1/x log x माइनस log y equal log of c, and this becomes log x minus log y log of x by y plus log of sec xy बराबर c, that is x by y sec xy equal to c. This is the solution of the given differential equation. Now we have to find the orthogonal trajectory of confocal and coaxial parabola r equal to 2a1 minus cos theta. We have to find the orthogonal trajectory of confocal and coaxial parabola r equal to 2a1 minus cos theta to the power minus 1. Okay. और पहले कोई क्वेश्चन था नहीं? ठीक, तो फिर वही चीज जो हम लोगों ने स्टार्टिंग में बनाया, पोलर फॉर्म, दिस इज 2a/1 प्लस cos theta, that is log r। इसकी कहानी शुरू में बता दी है मैंने, क्या काम करते हैं, डिफ्रेंशिएट किया 1/r dr by d theta, cos माइनस साइन माइनस माइनस प्लस sin theta upon 1 plus sin theta, and this becomes 2 sin theta by 2 cos theta by 2, sorry 1 plus cos theta is, here is cos theta, 2 cos square theta by 2, this becomes tan theta by 2, that is the equation becomes 1/r dr by d theta equal tan theta by 2. Now replace dr by d theta, replace dr by d theta by minus r squared d theta by dr, then equation becomes 1/r, and this becomes minus r squared dr by d theta by dr equal tan theta by 2 cancel, that is minus r d theta by dr tan of theta by 2, that is dr by r minus d theta tan theta by 2, and integrating, this gives log r equal minus cot theta by 2 d theta, and this becomes minus log sin theta by 2 1/2 plus log c, this becomes log r minus 2 log sin theta by 2 plus log c, and r equal c upon sin square theta by 2. Just multiply by 2. This gives 2c, 2 sin square theta by 2, 1 minus cos theta, that the orthogonal trajectory is your r equal 2c upon 1 minus cos theta is the required result. And the next question, d2y by dx square minus 2dy by dx plus y equal x e to the power x sin x. Okay. For complementary function 2m plus 1 equals 0, that is m minus 1 whole square equals 0, and it has two value 1 and 1, and complementary function will be c1 e to the power x, sorry, here this is your repeated root, and the CF will be c1 plus c2x and e to the power x. And for pi, this is 1 upon d minus 1 whole square x e to the power x of sin x. This becomes e to the power x into 1 upon d plus 1 minus 1 whole square of x sin x. This is your e to the power x into 1 by d square x sin x. That is e to the power x 1 by d square is your 1 by d into 1 by d of x sin x, integration by part, and e to the power x 1 by d. This is your integration of x sin x dx. Now e to the power x 1 by d, just integrate this x sin x, it is minus x cos x, minus x cos x, again x differentiation 1 minus cos x plus again cos x integration sin x. Now we have to integrate this one, that is e to the power x minus x cos x dx plus integration of sin x dx. This becomes e to the power x minus, integrate this, that is x sin x sin x and plus cos x d by dx of x1 cos x sin x, again sin x minus cos x minus minus plus, and integration of sin x will give your minus cos x. This gives minus taken as common e to the power x cos x 2 cos x plus x of sin x. Therefore, for complete solution, y equal if is c1 plus c2x into the power x minus pi 2 cos x. दिस इज द रिक्वायर्ड आंसर। आज थोड़ा सेशन लेट हो गया, थोड़ा लंबा हो गया, क्वेश्चन ज़्यादा थे इसलिए। नेक्स्ट में हम लोग देखेंगे, नेक्स्ट में पूरा डिफरेंशियल इक्वेशन जो भी बचा हुआ होगा उसको हम लोग फिनिश करेंगे। ओके, थैंक यू, होप यू विल लाइक द सॉल्यूशन।